Hello and welcome to the video on section 29.3 and 29.4. We'll be discussing simplifying radical expressions and radical exponents. Let's look at a few key rules for this section. The product rule for all roots states for all non-negative numbers, a, b, and n, just basically means a, b, and n are positive. The nth root of a times the nth root of b is going to equal the nth root of AB. And then vice versa, the nth root of AB equals the nth root of A times the nth root of B. That will be very important when we simplify radical expressions that are not perfect squares. Look at the product rule for exponents. X to the A times x to the B equals x to the A plus B, which you already know, just restating it. And then anytime we have a rational exponent, we can write it as a radical. As you can see here, we have x to the AB power. We can write that as the b root, of x to the a, or we can even use it as the b root of x to the a power. Let's go on and look at a few examples. First example here is we have the square root of 50. We need to find a perfect square that goes into 50. Right off the top of your head, you should see that 25 goes into it. So as the product rule states, we can turn this into the square root of 25 times the square root of 2. 25 times 2 is 50, so we haven't changed anything. So when we work this out, the square root of 25 is 5, and the square root of 2 is just going to be the square root of 2. It is not a perfect square, therefore we can't break it down anymore. Number 2, looking at a number to a fractional power. So as we showed earlier, we can write this as a radical. We know that the denominator of the exponent is going to be the root. So we're going to have the square root of 9 to the first power, because 1's in the numerator. The square root of 9 is 3. Number 3, we're going to look to simplify the square root of 48. We need to find a perfect square that goes into 48. We know that 16 times 3 is 48. We can double check ourselves. 16 times 3, do the 18, carry the 1, 3 times 1 is 3, plus 1 is 4. So we know we're correct there. The square root of 16 is 4. And we're going to be left with radical 3, because 3 is not a perfect square, and therefore we cannot simplify it anymore. On to a few more examples. Number 4, we're dealing with a variable. We have x to the 5th power. We want the square root of that. Since we're dealing with a square root, we want an even root. Or excuse me, an even exponent. So we can break this up into the square root of x to the 4th and the square root of x. So as we stated earlier, we can write the square root of x to the 4th as a fraction, a fractional exponent. So it's a root of 4, or exponent of 4 with a root of 2. So it can be written as x to the 4/2 power. Then we're left with root x. 4 divided by 2 is 2. So we're left with x squared root x. Another way we can look at this is we can look at the square root of x to the 5th. We have our little 2 that we don't write out there. We can say, how many times does 2 go into 5? Well, 2 goes into 5 2 times. 2 times 2 is 4, and we have 1 left over. So x to the 1st power, we don't write the 1. Let's look at number 5. Dealing with the cubed root of 54. So we need to find a perfect cube that goes into 54 this time. If we don't know, we can write a couple out. And with the sheets that you have been given, you will have a worksheet that deals with perfect squares, perfect roots, or perfect cubes, and perfect to the fourth power. So once you fill that out, you should be able to find these quite easily. We see that 3 cubed is 27. We know that 27 goes into 54 twice. So we're going to have the cubed root of 27, which is 3. Then the cubed root of 2. 2 is not a perfect cube. It has no perfect cubes in it. So we are going to be left with 3 cubed roots of 2. Same thing here with the cubed root of 24. We know 27 doesn't go into it because 27 is bigger than 24. Let's look at 2 cubed, which is 8. We know that 8 goes into that, goes into 24 3 times. So I have the cubed root of 8, which is 2. The cubed root of 3 is just going to be written as the cubed root of 3. Let's move on. We have another variable with an exponent underneath the cubed root. So we need to find a perfect cube, or excuse me, a number divisible by 3 goes into 20. Excuse me, a number divisible by 3 that is less than 22. Now, that's going to be 21. We're left with the cubed root of x. The cubed root of 21, the cubed root of x to the 21st, is going to be x to the 7th, because 21 divided by 3 gives us 7. And so we've taken care of the first one, so we're left with the cubed root of x. If you ever finish a problem and you are showing an exponent in the numerator, an exponent underneath the radical that is higher than the root, we aren't finished yet. As you can see here, there's going to be a 1 exponent on the x, which is less than the 3 root, so we are finished. Got another fractional exponent here, so we know we can write this as a radical. We can write this as the denominator is going to be my root. My denominator is 4, so I'm going to write a 4 for the root. And then we are left with x cubed, because we take the numerator to be our exponent underneath the radical. So as you can see, the radical, the 4th root, is higher than the 3, the exponent. So we are done. But we need to cube the 7. And 7 cubed is 343. So you're left with the 4th root of 343. Let's look at our next example, number 9. Left with the cubed root of 125. Then we have the cubed root of x to the 7th. We want that x to be, the exponent and the x to be divisible by 3, so we're going to make it a 6, and we're left with a cubed root of x. The y to the 4th, we need that to be cubed root of y cubed, and we're left with a cubed root of y. And the z exponent of 2 is lower than the root, so we're going to leave it just as it's written, the cubed root of z squared. So we try to simplify this. The cubed root of 125 is 5. The cubed root of x to the 6, we divide the exponent by the root. 6 divided by 3 is 2, so we're left with x squared. We still have our cubed root of x left. The cubed root of y cubed, we take the exponent, divide the root. 3 divided by 3 is 1, so we're left with a y out front. And we still have 1 y underneath the cubed root. And then with our z, 2 is less than 3, so we leave it as z squared. So we're left with 5x squared y times the cubed root of xy z squared. 3 more examples here to look at. Number 10, we see a negative underneath the radical, but when we check the root, it's an odd root. It's a 3, so we can work this problem. So let's remember our perfect cubes. 2 cubed is 8. 8 goes into 16. So I can rewrite this as the cubed root of negative 8, the cubed root of 2. Negative 8 times 2 is negative 16, so we haven't changed anything. Then deal with our x to the 4th. We see that 4 is greater than the 3, so we want to change the 4 to something that is divisible by 3, which is going to be 3, and we are left with the cubed root of x to the 1st. So when I simplify this, a cubed root of negative 8 is negative 2. I cannot do anything with the cubed root of 2, so we're going to leave it. We have the cubed root of x cubed, which we know is going to be x, and we are left with 1x underneath the radical. So my answer is negative 2x times the cubed root of 2x. Let's look at number 11. We have the quantity 3x taken to the 1/3 power. Now, as we were told earlier, we can write a fractional exponent as a radical. So let's make our radical. We know that from the exponent, our denominator of our exponent is going to be the root, so we're going to have the 3rd root, or the cubed root, however you want to pronounce it, of what we have in our parentheses, which is 3x, and that all goes to the 1st power, since 1 is our numerator. We don't have to write it as the 1st power, so we're going to write it as the cubed root of 3x. Our final example, we have a fraction with the same base and 2 fractional exponents. When we are dividing and we have the same base, we're going to subtract our exponents. So I'm going to have the base 2, and my new exponent is going to be 2/3 minus 4/3. 2/3 minus 4/3, we're going to subtract a fraction. We do have the same denominator, so we can subtract the top. 2 minus 4 is negative 2/3. As we learned in previous sections, anytime you have a negative exponent, you make it as a fraction over 1 and make the new exponent positive. So we're left with 1 over 2 to the 2/3 power. We're not done yet. We still have a fractional exponent that we can simplify. So we can write this as 1 over, make our radical. What is our denominator of our exponent? It's a 3, so we're going to have the cubed root of 2, and our numerator of the exponent is 2, so we're going to have 2 squared. So I can simplify and rewrite this as 1 over the cubed root of 2 squared, which is 4. Thank you for listening to this video, and good luck on your homework.